person.
Okay.
Yes, he does.
Chapter 12-8. Okay, first page is very, very simple. And we're talking about congruent and similar solids. This is basic review. Congruent, I'm just gonna do a little throwback. Congruent means same shape and size, okay? Same shape and size. And then similar just means same shape, but not necessarily the same size. The key part is basically sides are congruent, right? Sides are congruent, which is kind of obvious because they're congruent. So for similar, right, the sides are what? This is P. Sides are proportional. Good. Beautiful. Proportional. Okay. All right, so filling the blanks here real quick. Similar solids, again, same shape, but not necessarily the same size. So it's just saying two solids are similar if they are proportional, right? If the ratios of their corresponding sides are equal. And then jumping down to congruent solids. Oh, sorry, this is a fun fact. You should probably highlight this. All spheres are similar. If you have two spheres, you know, they're always going to be proportional because there's only one thing you're looking for, which is the radius, right? So the fact that you're only comparing one thing, they will always be in proportion. Yeah, proportional. Congruent solids, pretty simple. You know, it's 1-to-1, right? The ratio should be equal. Okay, so 1-to-1. And obviously, if they're congruent, it needs to be congruent. Okay, that's what all this is saying. Right? Corresponding angle is congruent. The faces are congruent. The edges are congruent. Okay, everything's okay. Real quick here. This is pretty obvious. Or there's two things you can, or one thing you can rule out. Determine whether the pair of solids are similar, congruent, or neither. Are they going to be congruent?
No.
No. Okay, so it can't be congruent. You can easily check that by just saying, okay, 3 and 6. But the only way they can be similar is if all of the edges or all of the sides are proportional. If one of the sides are not proportional, then it cannot be similar. You gotta check for all four. Ratio.
They're all proportional.
No, they're not. No, they're not. Yeah, they probably are. 1/2.
Are you judging by looks? Are you serious?
Yeah, Ephraim,
Come on.
You're not on it today, Ephraim.
No, I did it. I checked the proportions. They're proportional.
The hypotenuse.
Yes, they are.
5 and 10. Right, so it's 1/2. 1/2. The length. I just pretend that's 4. Really doesn't matter unless you make sure you match them up correspondingly. And then the height, 4 and 8. Okay, so they're all 1/2. So the fact that they all work out, the answer is that they are similar. Okay.
I told you so.
Copy frame. Okay, I think you guys can just quickly do 1, 2, and 3. So that's that one example. Just quickly do 1, 2, and 3, and then we'll check with each other, and we'll be done with the first page. Okay. I'm gonna pause the recording. Let's see. All right, guys. Well, here's your answer. Okay, so hopefully it wasn't too bad. So just to emphasize for the sphere, right? no matter what, if this is a sphere, they're always going to be similar, okay? Or congruent, right? One of those two. There's only one dimension you're looking for, which is the radius. So this is like, if this was for some reason like 0.5 inches, right? Well, then the ratio would just be 0.5 over 8, which was still, it's still a ratio because there's nothing else to compare it with. So this is its own similar ratio of itself. Okay. Backside. Oh. Right. Okay, for congruent and similar solids, part 2 over here, you're going to be comparing the surface area for the ratios and then the ratios of their volume. Please put this as emphasis, surface area. Okay, surface area, you're dealing with like inches squared, meters squared, right? Self-explanatory stuff, but just to emphasize, what number is here? You are squaring it, okay? For volume, right, the units are cube. So when you're talking about the dimensions, you always want to cube them. So it's really to emphasize that. And so essentially, your goal is to always find, okay, your goal is to always find, your goal is to find your scale factor first. Find scale factor first. Okay. We'll talk about some example problems of why we need to find scale factor first. And turn your, oh, who are you talking to? Oh, and I'm gonna mute everybody.
What is happening?
On your loud clock again. That happened in bio.
Oh, that's funny. Okay, thank you for muting. It's okay. It happens. Oh, there you go. Mute. Oh, I'm gonna mute everyone real quick. Just a heads up. So you have a question, just unmute or type in the chat. Okay. So, okay, you have your surface area. And what we're trying to do here is, so pretend you have AB. Okay, so highlight these. Like you have AB, A squared to A squared to B squared, A cubed to B cubed. Okay. So obviously it's pretty easy going down. Like if you're gonna go how to get to AB squared, you simply just square them, right? What happens? You would square this, right? You would square it. And what if you want to go from AB to the volume? What would you do? You would cube it, right? Okay, pretty self-explanatory stuff. What happens if I want to go backwards, right? If I want to go from here to here, what would I do? I would take the
Square root.
square root. Beautiful. Okay, just some throwback algebra, square root. And what happens if I want to go from, this is probably messy, this is probably not a good idea, but from here back to the scale factor, what would I do? Cube root, okay? Do we know what a cube root looks like? If a square root looks like this, boom, boom, that's a square root. Technically, there's an invisible 2 there for a square root, right? Like technically there's an invisible 2, just like kind of saying how there's always an invisible 1 in front of like variables, right? So same idea. So cube root, it would be a 3 here, right? Just a heads up. Okay, so that's like your process. Okay, so let's kind of do this is a baby example here. So 2 spheres have radii of 2 feet and 6 feet. Find the ratio of the volume of the small sphere to the large sphere. Okay. So right here, what dimension is this in? Is this feet squared, feet cubed? It's just a single feet, right? It's in one dimension. So it's one dimension. This is your scale factor. Okay, so you're given, these are your scale factors. Okay, this is your single dimension. And we're going from small to large, okay? So scale factor is 2 to 6. 2 feet to 6 feet, simplify to 1/3. Okay, always simplify your fractions. Okay, once you simplify it, how do I find the ratio of the volume? What would I want to do with this scale factor? I need to find the ratio of the volume, I would need to take the scale factor and cube it, right? I need to cube the scale factor. So 1/3 cube would get me 1/27. Boom, that's it, okay? Cool. You don't have to add units to your answer. No, you don't. Not for this one. It's just the ratio. So you're not, in the end, you're not really talking about any dimensions. This is just the ratio of the volume. I'll leave this here as a side note. RV, for shorthand, RV means ratio of volume. And then ratio of area, it will be RA, okay? Ratio of the area. Or surface area, okay? Area or surface area. Okay, that'll be my notation. You guys can use it too instead of writing the whole thing out. Okay. Okay, why don't you guys right now try 1 and 2 on your own. Okay, try 1 and 2, and then I will show you guys how to do it. Okay, so first one, a lot of you guys got it right, is 1/64. Okay, that was just like the example with the sphere. Okay, remember first step is to identify the scale factor. Okay, so that's your first dimension. And then once you have your first dimension, it's easy to get to your second or third, whichever you're trying to find. In this case, you're trying to find the third dimension, which is your volume. So you cube it, okay? Number 2 is a bit more tricky. This time you weren't given the scale factor, okay? You were given the volumes, okay? These are your volumes. So remember your first step, okay? Write this out, highlight it from above. Your first step, you need to always have your scale factor. But the fact that you're given your volume, to go back to your scale factor, you need to take the cube root, okay? So you have your volume here, you're comparing them. If you can simplify it. But if you can't, then 99% of the time, you should be able to take the cube root cleanly, right? Like taking the cube root of this, it ends up being 3/4, right? The cube root of 27, hopefully you guys know this, cube root of 27 is 3, and then the cube root of 64 is 4, okay? So this is your scale factor here, okay? And so now, how would I find the ratio of my surface area, or ratio of the area? Surface area or area, same thing. You're gonna take the scale factor, but now what should I do with it? Cube it or square it? You need to square it. Scale factor is 3/4. The answer is 9/16. Okay. Take a look. I get a thumbs up if you're good. If you have a question, please type it in the chat or say it out loud. Okay. Beautiful. Number 3, okay, last one, and then we're done. We're gonna do this one together, okay? Okay, there's 2 ways to do it, but I'm gonna emphasize the new way of how like the special, why it's kind of special with the new way. So right now, the question says a building company uses 2 similar sized pipes. Okay, the smaller size has a radius of 1 inch and length of 8 inches, and the larger side has a radius of 2.5 inches. Okay, so you can actually solve this using your old knowledge of similarity. So I'm gonna write this down. Okay, so you have your small pipe. Okay, your small pipe has a radius of 1 and a height of 8. Okay, and the large pipe, technically the only thing we know about it is that the radius is 2.5 inches. Okay, and so okay, I'm gonna do something here. Okay, what you technically could do, okay, technically you can find this height here. Okay, because they're saying they're similar, right? The fact that they're similar, you can set up a proportion for this, right? You can just do, if you're comparing it top to bottom here, you can do 1/8 equals 2.5 over the height. If you solve for this, your height would be, just cross multiply, right?
20.
What? Is it really 20? Yeah. Okay, so you could solve for your height. Okay, height is 20. And then simply for a pipe, what shape is that? That is a cylinder. Okay, a pipe is a, put in red. Pipe is a cylinder, right? So technically, if you want to find the volume, it's base area times height. And then you can plug it in and solve for the volume, right? I can do it real quick, actually. R is 2.5 squared times the height, which is 20, which is what we solved for. This should be about 2.5 squared times pi times 20. 392.7 inches cubed. Okay. We're cool with that? Yeah, that's the old school way. All right, that's old school. Because really all you did was the fact that you know they're similar, right? You can set up a proportion, right? Set up that proportion, find that height. Once you find that height, right, a pipe is just a cylinder, and you just plug it back in, okay? But let's pretend I want to spice things up, right? I want to spice up our life a bit. Let's pretend that I don't give you the height, okay? Let's say, or sorry, I don't give you this length. Okay, pretend, okay? Pretend I didn't give you okay, so we're gonna pretend that. So what can I do here is I know my scale factor. My scale factor is going to be 1/2.5, right? Because the radius is 1 and the other one is 2.5. Okay, that's my scale factor that I'm working with. Now I'm trying to find volume. So what should I do with this scale factor? 1/2.5, and I need to cube it. Okay, I'm gonna cube it. And this would get me, what would it get me? 1/15.625, okay? So bear with me, okay, that's the ratio of the volume. Okay, so now we can actually set up a proportion going this way, okay? So we know the ratio is 1/15.625 equals the volume of the small one over the volume of the large one. Okay. Oh, actually, you need that 8 curses. Okay. So ideally here, if I were to say the volume of the small one, this is given, okay? If I were to say it's 8 pi, okay, if you were given this, sorry, you actually need that information. If you were given this, right? So without knowing the height, okay, let's say you don't know the height, you're just given that the volume of this one is 8 pi. So this here would then be 15.625 equals 8 pi. And we're trying to find the volume of the large one. So now what I can do when you cross multiply volume of the large, I'm going to show my calculator here. Volume of the large is 15.625 times 8 times pi. That would get me 392.7 inches cubed. Okay. So essentially, both ways will work. Okay, it kind of just depends what you're given, right? Obviously, if you're given the height initially, then you can set up a proportion to find the height. Why would it be 8 pi? Yes, so Megan, this is given. So I'm just saying, like, if depending on the information you're given, right? If you're actually given this volume of the small, right? The volume of the small pipe, that's VS. Okay, volume of the small pipe. If you're given that, then you can use this proportion, right? Because this proportion here is the ratio of the volume. Okay, it's not the ratio of the heights, it's the ratio of like the actual final answer. Okay, so you might be using that during your homework. And yeah, so that just depends what you're given. Okay. So again, volume of the small pipe. Oh shoot. Volume of the small pipe and volume of the large pipe. Okay. All right. So that is it for the lesson.